Well, good morning, everyone, and welcome to Fearless Explorer Fridays. It's been a while since we've met, but we're very pleased today to have another speaker with us, Mr. Salah El-Ekhfifi from Benghazi in Libya. So welcome to the SEG Evolve students that are joining us here in the Zoom room, and thank you to everybody else that is joining us on YouTube. I'm just going to quickly share a few slides. And just, am I in full screen mode, Mario? And on the right screen?
We'll do the swap one more time, yes.
Swap, is that the right one?
Perfect.
Okay, anyway, so just a few quick notes. So these Fearless Explorer Friday meetings are brought to us courtesy of SEG and the SEG Evolve student program. And then we also have what we call SEG Evolve Professional, which is the same basic program that we do with the students, but we do it for early career professionals in oil companies, usually 0 to 5 years of experience. And basically, for those of you who haven't yet heard about SEG Evolve, hopefully there aren't too many of you out there in the world, but what SEG Evolve is a 6-month part-time virtual internship for students. As you know, many students look for internships. In fact, I've been receiving emails recently, people looking for internships, where SEG Evolve is a 6-month part-time internship. Of course, it's virtual. By the way, we were virtual before everybody came on Zoom. We've been doing Zoom for years ourselves. This is going to be our 4th year. And the key about Evolve is that it's collaborative. This is not a competition. People sometimes call it a competition. It's not. It's collaborative. It's global. This last year we had teams all the way to China and Malaysia. And it's inclusive, and we're focused on the future. And then we teach the skills that are necessary to be successful in those environments in the oil companies. And those environments are multidisciplinary. First of all, it's all the different disciplines. Of course, it's a digital setting. Everyone these days is working with often high-end workstations or at least PC-based packages. And here's the key. It includes extensive mentoring by highly experienced industry experts. I see a few of them here in the Zoom room. And this is a very hard thing to come by these days. The industry experts have kind of retired and disappeared. Well, guess what? We have them right here in SEG Evolve. And this is just to let you know here some of the different countries and teams that we have had in the last 3 years. So over 300 happy students, as we like to say, from more than 40 countries. And we're always looking to add, and all those gray areas, we want to fill them in. So in fact, we're going to need a team from Libya here one of these days. So anyway, these were our sponsors for 2020. We are actively looking for sponsors for 2021. So anybody who's got some of that extra money that's been given by the government and everything, and you want to share it with the SEG Evolve students, please feel free to go ahead and do so. So anyway, I'm very pleased today to have Mr. Salah El-Ekhfifi. And he is a geologist in the Libyan National Oil Company called National Oil Corporation of Libya. He has worked there for about 4 years, I believe. And he has done some work in the Cyrenaican platform. He's actually gone out and looked at real rocks. Many of us are in the business of remote sensing, whether it's images, seismic is remote sensing, well logs are remote sensing, but Mr. El-Ekhfifi has been looking at real rocks. That's the foundation of everything we do. So anyway, with that, I'm going to stop sharing. I'm going to introduce or turn it over to Mr. El-Ekhfifi. Welcome, and we're very much looking forward to your presentation. Thank you.
Is this clear now?
Perfect.
Okay. Good morning to everyone. I'm very glad to be with you today. First of all, I would like to thank the SEG colleagues or SEG people for the invitation to speak today. Also, thanks to all the participants today, and also thanks to the first author in this study, Dr. Khaled Amrouni. He is with us today. So thanks, Dr. Khaled, for being with us today. Let me introduce Dr. Khaled, PhD from Texas A&M, Sedimentology and Sequence Stratigraphy. And now he is joining Texas A&M as a postdoc researcher. So Dr. Khaled will be with us to share to answer the questions. So the title of this study entitled Reservoir Analogue, a case study from the Cyrenaican Miocene rocks, North East Libya. So in this study, 5 tools have been used to do this work. We use sedimentology for depositional environments. We use stratigraphy to understand the lateral and vertical relationship in order to deduce the sequence stratigraphic framework of the study area or of the studied basin, outcrop, platform. So we use also chemostratigraphy, carbon stable isotope analysis for correlation and also for organic productivity. And also we use diagenesis to understand the constructive and destructive stages of porosity. And we use the method handheld gamma ray scintillometer for correlation. Libya is a country located in North Africa, bounded in the eastern part with Egypt, in the western part with Tunisia, in the northern part with the Mediterranean Sea, and in the southern part with Chad and Niger. Here you can see the distribution of the sedimentary basins in Libya: Al-Khdar Basin, Morzuk Basin, Qadamis Basin, Sirt Basin. This is Cyrenaican Basin, and the study area is located here. And this is Tripolitania Subbasin, or Tripolitania Basin in the offshore, and this is offshore Sirt. Here in the location map, you will see the distribution of the 29 measured sections. You can see it by different colors here along 135 kilometers. The data available, or availability of the data, so 29 detailed stratigraphic measured sections along 135, as we said, 503 samples and 10 sections, 14 handheld gamma ray scintillometer profiles, and 4 carbon stable isotope curves. Al-Rajma group deposited on a gentry rand and includes 9 carbonate facies with 2 silicic acids. So the dominant succession is a carbonate, are the carbonate facies. So are the carbonates are the main dominant. So the peritidal facies and rand crest facies and subtidal facies. The peritidal can be like the evaporite, very fine quartz sandstone, green shale, peritidal workstone. So the ram crest is oolite greenstone, and subtidal facies like red algae reefs, reworked red algae, so pyroclastic carbonate, and also on. This is the sequence stratigraphic, or this is the general stratigraphy of the Cyrenaica. And you can see the stratigraphic succession starting from late Cretaceous to late Miocene. But in this study, we focus on Miocene. Here you can see the tectonic setting of the Cyrenaica platform and adjacent area. So 2 tectonic provinces have been occurred in Cyrenaica. You can see it here, Al-Jabal, Al-Khdar, Uplift, and Cyrenaica platform separated by Jurassic hinge line. So in order to correlate the Cyrenaican Miocene rocks, the datum was selected, or in order to do the correlation, the data was selected based upon the maximum flooding zone. Due to in the middle Miocene that has both high gamma ray and positive or carbon positive carbon isotope excursion. Then the stable carbon isotope curves were tied to the field measured outcrop stratigraphic sections and gamma ray vertical profiles. These are the three environments: pre-tidal, ramp crest, subtidal. Okay. Now this is the sequence stratigraphic. Now we are discussing briefly the sequence stratigraphic framework of the Cyrenaican Miocene. So this section roughly has been constructed from north to south, and the datum was selected on the middle Miocene. And here by different color, you will see the distribution of the studied facies, like yellowish color representing the oolitic greenstone. We can see dominant here in the middle Miocene, and also the belittle, the microbellids, also evaporites by the red color. And also you can see here the high carbon excursion. The high carbon excursion measured by carbon stable isotope, confirming the global event, Monterey event. And as you may aware, Monterey event was explored in Monterey Mountain in US, and then confirmed in many other countries like Malta, Italy, Japan, and here in Cyrenaica. So it indicates to high productivity of organic matter, and this reflects to presence of source rock in the deep marine. But as we know, we cannot evaluate it unless we do the geochemical analysis to understand maturation, the maturity level, corrosion type. So needs subsurface data in order to work in details with such or with this element, source rock. So also high gamma ray measured by gamma ray handheld scintillometer. Two micrographs of the porosity types. Here you can see different types or different secondary porosity types, as you see here: oomoldic porosity in oolitic greenstone facies, biomoldic porosity in coralline red algae facies, fenestral porosity in microbial facies, fracture also, and frame growth with also biomoldic porosity. So we try to also understand the effect of porosity on the Miocene rocks. So there are constructive and destructive stages of the genesis. So we noted, or we found that the middle Miocene is the best time for reservoir quality due to the fracturing, due to distribution, and while or also it has the highest average of porosity, middle Miocene, and the late Miocene has the lowest average of porosity due to cementation. Okay. Here you can see middle Miocene carbon 13 maximum readings and Monterey events. This is in our study. We proved it in Cyrenaica. This is the global isotope record. Here examples from Indian Ocean, from Italy, from Malta. So to confirm the global event, Monterey event. This is a measured section A1. The best important thing here to know, the average of porosity is 20% around, and the high porosity zones has been in the middle Miocene. So in the middle Miocene, we have high porosity zones, we have high carbon, high gamma ray, three dominant facies. It could be a good reservoir, like oolitic greenstone, coralline algae, and reprinted reservoirs, or microbial reservoirs, or microbial facies. This is an example from the neighboring basin in Zohr field. as we were they tapped by the succession there tapped by Messinian crisis, like also in Libya and in most of other Mediterranean countries. And here the type of source rock Miocene. The reservoir, in the last time they think the reservoir is a Miocene, but after several studies, the ENI people, they proved this reservoir as or in Cretaceous age. So they have done a good age dating studies. So the type of reservoir, Cretaceous, but the most important thing here, the type of source rock is Miocene. As we have a good results in Miocene Cyrenaican outcrops by stable isotope to have high carbon excursion that indicates, as we said, to high productivity of organic matter. In this case, these results are encouraging us to focus on the deep marine to look for or to evaluate the source rocks. So we can conclude that this work of the Cyrenaican Miocene Rajma group carbonate platform rocks records second order sequences, third order sequences on the integration of stable carbon-13 isotope data with gamma ray. Also, the RAM system, this RAM system, the subtidal correlated algae dominated the early Miocene and gradually replaced by shallower ramp crust or little greenstone and peritidal restricted microbial fascias in the middle to late Miocene. Also, the Langian and all the fascias are dominated by biomolded porosity and framework or frame growth porosity in the coralline algae. The Ceravelian and younger fascias are dominated by oomoldic and fenestral porosity. Also, a Rajma group sequence contains 3 fascias, fracture considerable vertical thickness, lateral continuity, and high secondary porosity. These criteria make the Cyrenaican Miocene rocks as a good analog for subsurface studies. According to the surface analog study, the Miocene petroleum system can be recognized as the 3 types of reservoirs can be good reservoirs, potential good seal representing by Miocene anhydride section. In fact, we have 2 different rocks that could be a good seal, the middle Miocene and late Miocene shale. So potential source rock indicated by high carbon presence in the middle Miocene section needs to be maturity proven for production of organic matter, and pathway of migration can be internal within Miocene or external out of Miocene rocks. So thank you for your attending the presentation, and welcome to ask any question.
Okay, well, thank you, Mr. El-Ekhfifi. If you want to unshare your screen then.
Yes.
So at this time, we will open it up for questions within the Zoom room itself. If anybody wants to address any questions directly, we also are taking questions from the YouTube attendees through the chat. And I believe, Mario, you'll be receiving that and sharing that with me in the chat as you get some of those questions.
Yes, and I do have one question. I wanted to know the significance of the carbon isotope charts and why there's so many different ones of them, and what's the significance of the Monterey event in terms of your analog. And you can share the screen again if that's easier to answer the question properly.
So some clarification on the carbon-13 methods and display.
Yeah. Can you ask again, please?
So yes, my question is the significance of the carbon isotope study part and why the difference you're comparing them, and the significance of the Monterey event that I saw you highlighted through that middle portion of it.
As I told you, the Monterey event is a global event. Mm-hmm. From the carbon, in order to study stable isotope analysis, you have to go through two parameters, carbon and oxygen. So you study the oxygen in order to understand the paleoclimates, and the carbon in order to use it for correlation and for organic productivity. Why we use in the correlation? Because we have some carbon signatures have been repeated in several countries. So when the scientists did some studies regarding the age dating, they noted or they found good results that there is a relationship between the age and these global events. So each time has its own signature. Yeah, like Eocene time, Miocene, Cretaceous, but the Monterey is only on Miocene. We have another events with other ages, like in Miocene, like in Cretaceous, Oligocene. So, yeah.
So basically a global event, yeah. And
yeah, I need to add something here for the carbon isotope. So basically, it does two things. The second thing is the correlation. As a stratigraphers, we use it. The first thing was for paleochemistry. So when there's high excursions of carbon, we know there is high organic productivity, which means there is potential source rock.
Okay.
yeah. So, Dr. Amrouni, since you spoke, we know that you're a very prolific author. We've seen many of your papers, but tell us a little bit more so we have a context. What exactly, you must have a series of studies going on at Texas A&M here just up the road about an hour from us.
Actually, I changed my major completely after being PhD in geology. Now I'm doing data science, because I believe there's a lot. The geology science is too much descriptive, and we need to transfer to the next level to be quantitative. And I believe now I'm at the level that I can transfer this descriptive, like, knowledge to give it a soul, life, and becomes quantitative. And I just finished my data science program, which was 29 courses. I did 29 courses, and December 1st was my graduation. I finished it.
Okay.
So this common step, to change this stratigraphy and sedimentology into quantitative science, besides the qualitative science that we have tons of qualitative material, but they're dead. They need to be transferred into numbers. Yeah.
But so I understand, is there like an effort at A&M to specifically study Libya? It seems like there've been a lot of papers on Libya coming out, or is that just because you were there? I mean,
I was there, me and my team. Yeah, I was there.
Okay, so it was just because you were there. It's not like they have another program separate from you that is about studying the geology of Libya.
No. I was a sleepless person, doing a lot of work.
I think we would say welcome to the real world, right?
Yeah.
So, okay. Do we have any other questions in the chat here at the moment, Mario, from YouTube?
No, currently.
Okay. So, Mr. El-Ekhfifi, the other day, actually, you and I sat down and we had a map of all the exploration permits of the Mediterranean, and we looked at the permits offshore, and of course the exploration permits in Libya, all the way to Zohr and everything. So are there kind of any general comments you want to make about the overall sort of South and Eastern Mediterranean region and how your study sort of impacts some of that? Can you tell us any good permits that we should be pursuing or anything like that? Mr. Laguros has to write a newsletter here soon, so anything you can give him, I bet would be very appreciated. But yeah, your thoughts on the general region and how you're, like you said, are we going to find some more big discoveries in the area, you think, or?
So these results are, as I said, the first time of the presentation, are preliminary results. So the next stage is to go to work on the integrated surface to subsurface data in order to collate them together, and also to tying the seismic with some drilled or previous wells in order to have the clear picture to confirm the petroleum system elements of the study area, and then to know about the potentiality, because we need to evaluate each system, each parameter, source rock, reservoir. Also, trap has to be evaluated carefully within dedicated exploration program like 3D seismic.
Mm-hmm.
Yeah.
So maybe one question along those lines, is there any seismic and well data in Libya that is actually public domain, or is everything only associated with exploration permits and constrained and kept within the operator?
Yeah, in fact, most of the seismic surveys are from the owner companies, but there is a good 2D geological or seismic survey passing through Libya has been done by ION Geophysical Company in US. So this work has been done in 2014. Some of this data are bought or are bought by Spectrum. As we may aware, Spectrum working closely with Greece or Greek governments. So they have reported some papers. They stated to presence a good geological structures. It could be similar to Zohr, and they call it Zohr Analogue, southwestern offshore part with Libya, 7 kilometers. And I think these results are encouraging us to focus on this zone between Libya and Crete. And you can see it online. After the presentation, I will send it to you. I will send to you these links in order to see that. So this is the only seismic, or this is the only seismic information about the area, about the areas close to the Cyrenaica, because most of the other works for the owner companies working there, like PP, so.
Okay. Well, thank you.
Very encouraging. Yeah.
Well, I believe really that, the Guyana area offshore South America is one of the hottest areas in the world. Again, Mr. Laguros can probably correct me if I'm wrong, but one of the hottest areas. And I think this whole Mediterranean corner is probably one of the other really hot areas in the entire world. So that's sort of an impression. Mr. Laguros, you want to correct me or give any other comments?
You're absolutely right. And you stole my question.
Oh.
But that's okay. That's okay. I would ask though, since I'm not really familiar with the basin, what type of or how much production is coming from that basin? Do they have some rather large fields there? What has sort of been the exploration and production history of the basin?
So it is not easy to answer this question because I need a permission from my company to answer. Yeah. So out of my control. So I'm the guy. So that's.
Yeah, and I'm not looking for any details. Just are there some major fields there? Just very high level.
No problem. But after this presentation, we can chat and discuss to give you some highlights about the general geology and the previous activities have been done on the Mediterranean Sea, on the areas close to the Cyrenaica and close to the offshore Gulf of Sirte. But I only can tell you two exploration discoveries, have been done on the Gulf of Sirte. The first has been done by REMSA, and the second has been done by his company. They announced their first exploration discovery. Gas, not oil. They call it Arus al-Bahar exploration. You can search on the internet. You can find some information about this activity. So thanks for your question.
Let's see if any of our other mentors here in the room have any questions. And let me see. Oh, I see you've written something in the chat, so I'm going to have to read. Let's see. Somebody asked a question here about how accurate is the isotope work? What is the accuracy? This is Mr. Ali who's sending this note. And then are there other methodologies that you could have also used to, I guess, corroborate your analysis?
The accuracy here depends on the accuracy of the machine itself. Yeah, it depends where you send, which lab you send your data to. So we did this data in Texas A&M, the facility. They have really good facilities there, and the accuracy was really good, acceptable. But I don't remember the numbers exactly, to be honest. But it depends on the machines where you send your data.
Yeah. And I guess this Monterey event, I mean, that's the same one that produces in California, right?
Exactly.
Exactly.
Yeah. Yeah. And they have great big wrench faults there, by the way. I remember that when Exxon was exploring that area, you know, they were exploring chert reservoirs, which was very unusual at the time. And B, you know, the structural style there in California is these strike slip faults.
Yeah.
And
I was in California 5 days before my graduation, my PhD defense. Yeah, I was there just to do the Monterey thing.
You know, it's funny because with all these experienced mentors, we share a variety of experiences. But, you know, companies, they sometimes build up, what do I want to call it, accepted knowledge. And you know, I do remember, because I've sat in presentations talking about the Monterey and wrench faults. And there would be pretty much at Exxon at the time, people said, if it's a wrench fault, it's always going to seal. So I don't know if our thinking has developed since those days, but certainly that was one of the thoughts at the time, that because of the lateral movement, people said, oh yeah, the wrench faults have a very high probability of sealing. So
yeah. And there's another thing about the Miocene time. It's a very interesting time because, you know, the water passages or pathways global wise changed completely from east-west warm water, the Tethys, the Paleotethys, like the Mediterranean now, we call it like Neotethys. The Paleotethys was closing during that time, which was east-west, like equatorial passage into north-south, the Atlantic now. So the paleo water passages system just changed completely by the end of middle Miocene, where the closure happened, and the water flow becomes north-south instead of being warm equatorial east-west. So you find like a lot of changes happened, and the closure of the Paleotethys started all the way from the eastern side of the Mediterranean when the Arab Peninsula hit the Eurasian continent and start closing as you go west until you hit Gibraltar and go all the way to the Panama Canal. So it's really big, like the whole thing closing, changing the system, the water system from flowing from east-west, warm, nice water, good for corals and all this stuff to grow up, to north-south, cold and hot, warm water, and that water circulation is happening all the time. You know, it's like it's transformation in the paleo water passages. You know.
Okay.
Yep.
Okay, let's see, any other questions from our Zoom room at the moment? And I guess nothing else in the chat here from our YouTube friends watching. So last chance for the mentors to have any other comments. And if not, I'll just sort of close out here quickly. And let's see, I'm going to my turn to share. So again, thank you, Mr. El-Ekhfifi, Dr. Amrouni.
You're welcome.
Great to have both of you, and good luck in your ongoing activities. And as we say, it's a small industry. Our paths will cross again soon, I'm sure. So,
and by the way, I think Mr. Salah, he's the youngest, the junior in our team, and he's doing a lot of efforts, and he's really working hard. And I always encourage him, go ahead. Just you need to gain more experience, contacting people, exchange ideas, and you'll be fine. This is how to gain it. And we thank you guys for giving him this opportunity to share his ideas.
Well, again, this is the this group of the next generation. These are what we call them, the fearless explorers of the future. You got to know each other. You've got to maintain your networks. You got to learn a thing or two from those of us who've been around for decades. There may be one or two things we can teach you. And other than that, yeah. So thank you to both of you. Look forward to talking to you again. I'll just kind of quickly close out here. And again, Mario, confirm if I've got the right screen or if I need to do a switch. Am I on the good screen or shall I switch? Switch?
Good. Switch.
Yeah.
That's it? Okay, well, for those of you who are watching on YouTube, if any of this is new to you, we hope you enjoyed today's presentation from Mr. El-Ekhfifi. If you're interested in learning more about Evolve, we have a lot of information out there. You can go to the SEG website. And as we said, also Evolve Professional. This is something that's done by SEG and through a separate entity that we call Next Gen Training Partners. So please feel free to go find out information. Of course, we'd love you to subscribe to the YouTube channel and follow us on LinkedIn and so on. But stay in touch with SEG Evolve and SEG Evolve Professional. By the way, for everybody, it's not too late to sign up for the Evolve Professional January to June 6-month virtual training for the people with 0 to 10 years of experience. So come on in, join us, and we'll make you have an experience of coming before the executive table and presenting to senior managers. I'm sure you'll find that very useful and enjoyable. So anyway, thank you very much for attending today, all of you on YouTube, all of you in the Zoom room, and we look forward to seeing you at our next Fearless Explorer Fridays. Thank you very much.
Thank you very much.